Hello everyone. Now I'm going to take inner product space. First, we can see the definition. Inner product space. And in an inner product space an inner product space on a vector space V. On vector space V is a function. This is a function is denoted by, we can denote the inner product space as like this, is a function which aligns, which aligns to every pair of vectors, which aligns to every pair of vectors. Then the following condition should satisfy. Then the following conditions, then the following conditions are satisfied. Are satisfied. First one, first condition. Inner product of U, V bar conjugate. Inner product of U, V conjugate is equal to V, U. So this is the first condition to satisfy the inner product space. Second one, inner product of U, U is equal to, is greater than or equal to 0, and inner product of U, U and inner product of U, U is equal to 0 if and only if U is equal to 0. This is the second condition. Final one, third, inner product of alpha U plus beta V, W is equal to, two scalars are there in this. You take the scalar outside, alpha of first vector U, last vector W, plus take the second scalar outside, beta. This is beta. Beta, inner product of second scalar vector and third vector V, this is the definition for inner product space. Okay. An inner product space on V is a function which aligns every pair of vectors. Then it should satisfy three conditions. U, V bar is equal to V, U. U, U is greater than or equal to 0, and U, U is equal to 0 if and only if U is equal to 0. And inner product of alpha U plus beta V, W. Three vectors, two scalars. Take first scalar outside, first vector and third vector, plus take the second scalar outside, beta, second vector and third vector. So this is inner product space. Okay. inner product space definition. Now we can see note. Right? Note. So you need to know what is norm of u. What is norm of u? Norm of u is equal to root of inner product of u comma u. Okay? Or norm of u square is equal to inner product of u comma u. Okay? You would have keep this in your mind. Okay? First one. Now second, note number 2. Standard form of inner product. Standard form of standard form of inner product. Inner product space. What is the standard form? U comma V. Inner product of U comma V is equal to what is standard form means? A1 B1 bar plus A2 B2 bar. Second term you will take the conjugate plus A3 B3 bar. This is a standard form of inner product space. Okay. Now we can see the third note. Third note. You need to know what is Cauchy-Schwarz inequality. Cauchy-Schwarz inequality. Just you have a glance of this one. Modulus of u comma v is less than or equal to norm of u norm of norm of v. Okay. Final one. Triangle inequality. Triangle inequality. Norm of u plus v is less than or equal to norm of u plus norm of. So these both inequality are very important. Okay. So second one, note number 2 is a standard form of inner product space. 3 and 4 are the inequality. Cauchy-Schwarz and triangle inequality. So have these notes in your mind. Okay. Now we will try to prove some sums. Okay. Okay. Now I will try to prove one sum. First one. Prove that norm of u plus v the whole square plus norm of u minus v the whole square is equal to 2 norm of u square plus norm of v square. So we will try to prove this these things. Okay. So first you take LHS. Okay. Norm of first using first node, you expand this one. What you will get? Inner product of, I am taking LHS, inner product of U plus V, comma, U plus V. I expand this first term. Now I am expanding second term of LHS plus inner product of U minus V, comma, U minus V. Now usual multiplication, U into U into U. That is U, comma, U plus U and V. U, comma, V plus VU, V and U. V, comma, U plus V, comma, V. V, comma, V. I have simplified this term. Then I am going to simplify second term. Again, plus U, comma, U. Inner product of U, comma, U minus. Since you have negative sign there, minus U, comma, V. U, comma, V. Then minus inner product of V, comma, U. Minus into minus plus. Plus inner product of V, comma, V. Now you can cancel the terms. Inner product of U, comma, V and minus U, comma, V get cancelled. Then inner product of V, comma, U and minus V, comma, U get cancelled. Then balance you will have 2 inner product of U, comma, U. Since you have 2 inner product of U, comma, U and 2 inner product of V, comma, V plus 2 inner product of V, comma, V. Okay. So according to note 1, what we can write for U, comma, U? 2. We can replace this as norm of U square plus 2. Inner product of V, comma, V can be written as norm of V square. Now you take 2 common. Norm of U square plus norm of V square. That's it. So this is the simple proof. This is RHS. Okay. So now we'll try to prove another question. Second one. Using inner product on inner product space on R cube. Show that U is equal to minus 3, comma 1, comma 0. B is equal to 2, comma minus 1, comma 3. Full stop. Satisfy first one. Cauchy-Schwarz inequality. CS is Cauchy-Schwarz inequality. Second one, triangle inequality. Triangle inequality. So we are going to use note 3 and note 4. So I'm trying to prove first subdivision Cauchy-Schwarz inequality. Cauchy-Schwarz inequality. What is Cauchy-Schwarz inequality? What is Cauchy-Schwarz inequality? That is a note 3. Okay. For that, modulus of inner product of u comma v is less than or equal to norm of u, norm of v. So now you first just find inner product of u comma v. So what is u here? What is u? Inner product of u minus 3, 1, 0, comma. What is v? 2 minus 1, 3. So usual multiplication, minus 3 into 2, minus 6, corresponding elements, minus 1 into 1, minus 1, 0 into 3, 0. So your answer is minus 7. So LHS, you need to take modulus also. If you take modulus, this is u comma v. So take modulus of u comma v. Minus 7 will be positive 7. Okay, this is your left hand side. Okay, now you prove right hand side. Find norm of u. You know norm of u form. Note number 1. Inner product of u comma u. Inner product of u comma u. So root, what is u? Minus 3, 1, 0, comma, minus 3, 1, 0. Okay, now you multiply. Now you multiply. 3 into 3, 9. 1 into 1, 1. 0 into 0, 0. So your answer is 10. Your answer is 10. I have forgot the root. Your answer is root 10. Similarly, find norm of V. So formula is inner product of V comma V, inner product of, what is V? 2 minus 1, 3, comma, 2 minus 1, 3. Root 2 into 2, 4, plus 1, plus 3. So root 8. Root 8 is your answer. Okay. So now I am erasing only the question. Okay. So what is RHS norm of U, norm of V? So you multiply both. Root 10, root 10 and sorry. Yeah, 3 into 3 is 9. Okay. 9, 10, 11, 12, 13, 14. So yeah, this answer is 14. Simple mistake. This answer is 14. So what is your root 10, root 14? You will get root 140, which is approximately equal to 11.8. This is your RHS. So compare with this. What is your LHS? 7. From here, you know LHS is 7. And inequality is less than or equal to 11.8. So the condition holds. So like this, you have to satisfy triangle inequality also. Okay. So I'm erasing this one also. Okay. Now we can prove triangle inequality. Triangle inequality. Second one. Triangle inequality. Second one. Triangle inequality. So what is note 4? Norm of u plus v is less than or equal to norm of u plus norm of v. So take LHS, norm of u plus v. First, want to know what is u plus v. Okay, what is u plus v? So what is u? What is u? Minus 310. Minus 310. What is v? 2 minus 1, 3. 2 minus 1, 3. You add these two things. Minus 3 plus 2 minus 1 minus 1, comma 1 minus 1, 0. 0 plus 3, 3. This is u plus v. Okay. Now immediately find norm of u plus v. Norm of u plus v is equal to root. And you have to multiply square the corresponding term. Minus 1 into minus 1, 1. Plus 0 into 0, 0. 3 into 3, 9. So root 10. This is your RHS. Sorry, LHS. This is your LHS. Now you take RHS. RHS. Find norm of U. Norm of U. You have already find from first using Cauchy's integral. Norm of U is equal to root 10. Norm of V is equal to root 14 from first Cauchy's odds. Now you have to add both plus norm of V. So root 10 plus root 14. So this is your RHS. So now we come. Whether you check it's satisfied or not. Root 10 is your LHS less than or equal to root 10 plus root 14. So root 10 plus root 14 approximately you can write as 6.90. Root 10. Root 10 means what? 3.16 less than or equal to 6.90. It holds. It holds. So like this, you have to prove Cauchy's and triangle inequality. Okay. So what and all we have discussed up to now? We have discussed inner product definition. Inner product definition. These three conditions should satisfy. Next, we have seen the note for Cauchy's and triangle inequality. Next, we have proved one simple sum. Next, we have proved Cauchy and triangle inequality. Okay. So now next we can move to next topic. We can move to next topic.